Today we are going to talk about section 3.1. We're skipping ahead. Linear inequalities. We will come back to chapter 2 next week. And this is, I think, the only section we're going to cover in this chapter. But it does make sense to talk about this now in terms of what else we've been learning. Okay, so in life, sometimes it is more important that a quantity be larger than 0 than equal to something. So in high school math, right, usually what you're doing is you're always solving equations, right? You're finding the exact value where something happens, right? But, right, if you're running a business, you just want your profits to be positive, right? You don't want them to be exactly 0. You want them to be greater than 0, right? And the more bigger than 0 they are, the happier you would be, right? So inequalities are often much more important than equalities. So we're going to talk about how to solve linear inequalities. So an example, we want to solve x plus 4 is bigger than 3. What we're saying is we want to find what x's will allow x plus 4 to be bigger than 3. And of course, perhaps we remember how to do this. We subtract the 4 from each side to isolate the x. And now you have x bigger than -1. Right? This is the solution. What numbers, when you add 4, are bigger than -3? The answer is those numbers which are larger than -1. Okay. Any questions about? Right? Now, there are 3 rules to solving inequalities. And they're very similar to the rules for solving equalities, except for the third one. The first one is if A is a bigger number than B, then if we add C to A, it's still bigger than if we add C to B as well. So if A was bigger than C and we add C to both A and B, A plus C is bigger than B plus C. And this is also true if we instead subtracted C. So we write that as plus or minus. So the step of subtracting the same number from both sides is a valid step in solving linear inequalities. The second rule is if A is bigger than B and C is larger than 0, then A times C is bigger than B times C. Right? If you start with one number that is bigger than another and you multiply both of them by the same positive number, then the product of the larger number is bigger than the product of the smaller number with that new number C. And that's similar to the rule with solving equalities, is that you can multiply both sides by a number. Right? But of course, the third one is the one that's a little different. It is also about multiplication. If A is bigger than B and C is a negative number, then when you multiply the inequality, the sign on the inequality flips around. Are we familiar with that? Have we seen that before? I imagine it's probably true for almost all of you. So that's the only thing we got to be careful about when we're solving inequalities versus solving equalities, is that when you multiply by a negative quantity, you have to change the sign of the inequality. So let's do an example of how this works then. If we want to solve 2x plus 4 greater than 6, we want to know what x's will allow 2x plus 4 to be greater than 6. Right? Perhaps you can do this in your head, but we can also do this with algebra. This is fine. So we subtract the 4 from both sides. That's property 1 above. And we get 2x bigger than 2. Then we multiply both sides by 1/2. That's property 2 because 1/2 is a positive number, and we get x bigger than 1. So as long as x is bigger than 1, it is true that 2x plus 4 will be bigger than 6. And of course, what it means to solve an inequality is to get down to a bold statement where you isolate the one variable and say it's larger than some number. Right? That's what it means to solve. Okay, how about solve negative 3x plus 2 is bigger than or equal to negative 1? We start again using property 1 by subtracting 2 from both sides. This is property 1. We get negative 3x is bigger than or equal to negative 1 minus 2 is negative 3. Now, in order to isolate the x, I need to multiply both sides of this equation by negative 1/3, not 1/3. So I have to multiply by negative 1/3. That is now step 3, and when I multiply that, it switches the sign around. So on the left-hand side, I now have x, then I have a less than or equal to sign, and on the right-hand side, I have 1. So when we multiply by a negative number, we have to switch the direction of the inequality. Okay? And that's because 5 is bigger than 4, but when we multiply them by negative 1, negative 4 is bigger than negative 5. This is why we have to multiply those things by numbers. Okay. Now, we can also, so far we've only done inequalities with one variable, but we can also write inequalities in more than one variable, like this example here, 2x minus 3y bigger than negative 9. We want to graph this. So, when we graph an inequality in x and y, we want to first we want to graph the equality, right? We want to graph the line 2x minus 3y equals negative 9. That's the first line we want to graph. And how would we do that? Well, you might have your own favorite method, right? But usually the way that we do that is we isolate the y and get it in slope-intercept form. That's probably the most common way in which you're used to graphing lines, right? So let's isolate the y. So that means subtracting the 2x from both sides. So we get negative 3y is greater than or equal to negative 2x minus 9. Now, what we need to do is multiply both sides by negative 1/3. That's going to switch the sign around. And I haven't multiplied that through because I didn't want to do too much in one step, right? But on the left-hand side, I multiplied negative 3y times negative 1/3. And then I just get y. And then I switch the sign on the inequality around. And now I have negative 1/3 times this quantity. So I, of course, need to put this through. So this is 2/3 x plus 3. Okay. So now I've gotten it into slope-intercept form. So now I'm ready to graph this line. So step 1, maybe say, is slope-intercept form, which is not an essential step if you can graph without getting into slope-intercept form, if that's comfortable to you, right? But if you'd rather just use slope-intercept form, fine. Step 1 is slope-intercept form. Step 2 is graph the equality. So here, let's fix this to be the origin. No, that's a bad origin. It's too low for what I've got here. Let's give myself some room. There's the origin. And the intercept is 3. So that point is there. And the slope is 2/3. So I go over 3 and up 2 to get another point, right? That's how slope works. The slope is 2 over 3. So going over 3 and up 2 will give the right sort of thing. Now we will attempt to draw a line somewhat straight. Get a straight edge here. So there's our line. Now we're not done though, because this line is y equals 2/3 x plus 3. We want to know what the graph of y less than or equal to 2/3 x plus 3 is. So what's going to happen is either the area above that line or below that line will be the solution. One of those two things will be true. So how do you decide which of those two things is true? Well, you may have your own way of doing it, but what I like to do is I like to test the origin. Now, unless your line actually goes through the origin, then you can't use this to test. But this is the point I usually like to test. If I plug in 0, 0 into this equation, I get 0 less than 2/3 times 0 plus 3. And then when I simplify that, I get 0 less than or equal to 3. Is 0 less than or equal to 3? Yes, 0 is less than or equal to 3. So that means that the origin belongs to this inequality. And that means the actual graph of the inequality, then we want to shade everything underneath the graph. So that's what our answer should look like. It should look like a graphed line with a shaded area. Any questions about that process? Yeah, Natalie. I'm sorry, not Natalie. Haley.
Yeah.
Yeah.
Could you not just say the y is going down, so just shade it down there?
What? Y is going down because y is less than or equal to?
Yeah.
Yeah.
Okay.
Yeah, if you have a mnemonic where it's a y is less than or equal to, it's below the line, and y is greater than or equal to above the line, that's fine. I just know that a lot of people get confused with inequalities, and so one way to do it is take a point that's clearly on one side or another and see if it's true. And if it's true, that's the side you color. If it's false, you color the other side. If you have a better way of doing it or an easier way that's worked for you before and you've had success with it, it's totally fine with me. Yeah.
Does
Jake.
the line change if it's not greater or less than equal to?
Yeah, so I guess if this was y less than 2/3, I should probably have that line be a dotted line, right? Maybe we'll do an example like that. Yeah, we'll do an example like that next. Right? If it doesn't include the line should be dotted, but this one does include the line. Any other thoughts before we move on to another example? All right. Uh, 2x plus 3y is bigger than 15. Okay, so we're going to do the same thing we did before. We want to isolate the y. So I subtract 2x from both sides. When I do that, I have 3y is greater than negative 2x plus 15. Then I divide both sides by 3. Since 3 is positive, I don't need to change the sign. 3 divided by 15 is 5. So I get y greater than 2/3 x plus 5. All right. Now we're ready to graph the equality. Let's make this the origin. And I've got graph paper here, so I don't need to write axes or anything. It's kind of implied. So there's 1 point. There's the y-intercept at 5. And the slope is negative 2/3. So if I go down 2, I need to go over 3. Okay. So there's a second point on this line. Any questions about how I graph those points? Is that okay? Did we get that? Okay, now I need to draw the line, right? So, but this one's a strictly greater than, so my line should probably be a dotted line. Like that. A dashed line, perhaps. More than a dotted line. Now, y is greater than negative 2/3 x plus 5. So, as Haley noted, I could just color above, right? But let's check the origin as well. what happens is 0 greater than negative 2/3 times 0 plus 5? Is 0 greater than 5? No, 0 is not greater than 5. So that means the origin is not in this region, so that means I want to color this region there. Any questions about this second example of graphing? Good. Okay. Another possibility that we might be looking at is graphing a system of equations, or inequalities rather. So let's say we were going to have 2x plus 3y bigger than or equal to 15, 4x minus 2y bigger than or equal to 12, and y is bigger than or equal to 0. In some situation, we want all three of these inequalities to be true. So we're going to graph all three of these inequalities and then highlight the region on which they are all simultaneously true. So now it's going to take 3 times as much work because we have 3 different equations. The first step is to get into y equals mx plus b form. We just did that with this other one here. This is the same equation that we just did, except it's a greater than or equal to instead of greater than. So this is y is greater than 2/3 x plus 5. Right? That's just copied from the previous example. Okay. The second one, if we were to solve this one, we would have y less than or equal to 2x minus 6. When we get that in y equals mx plus b form. I just did that in my head, right? We've done that a few times in class today already, so maybe it's not worth wasting the screen space to do it again. If I'm wrong on that transformation, please let me know before we go too much further, but I think that's correct. And then this one's already in good form for us, y bigger than 0. Okay, so now what we want to do is we want to simultaneously graph all 3 of these inequalities. So we got to pick our origin. The first one we already did, right? That's this one here. Oh, and now it's a solid line because it's a greater than or equal to. And I'm just going to choose a color here. You don't have to use colors when you're doing this. It's not a problem, but since I have colors at my disposal, I'll do that really relatively easily. Now we want y less than 2x minus 6, so I need to plot that. Negative 1, 2, 3, 4, 5, 6. So we've got this point here. And the slope is 2, so we go over 1 and up 2. So that is this line here. Draw this with a straight edge, make it look nice. Okay, now we want y to be less than 2x minus 6. If I plug in 0 into that, I would get 0 less than or equal to negative 6, which is not true. So I'm not on the side of the origin of this line, I am on the other side. So that blue region is the second inequality. And now the last one, we have y is greater than or equal to 0. That's plotting the line y equals 0. And then y is greater than 0 means we're going to color everything above it. Okay, so the region, the important region, which has all 3 of these things be happening, is this one right here. I'm going to highlight it with an extra thick black line there. This is the region where all 3 of those inequalities are true. Any questions about that example? You okay? Great. Okay, I'm going to write up the warm-up in class exercises and the homework right here. Then I'll stop the video and you guys can get working. And then the homework, which will be due Monday. There's nothing going on this weekend, right? There's only 2 football games, so you should have time to get this done. All right.